Okay, so today I am going to be talking about the quotient rule. As I said in the last video, there are times when you have a particular set of functions that you have to do the derivative of, but you can't simplify that fraction. You can't simplify that division that's going on. So what you're left with here is you're left with two functions and you have to do its derivative. There isn't anything where you just do the derivative of the top and the derivative of the bottom. That doesn't work in this case. So to basically do the derivative of a quotient, we have to use this rule. And I don't typically like to teach in this format where I give you the rule and then just show you how to use it. But it just seems to be the best format for this particular topic. So what I want you to notice, first of all, is how to use this. There are two functions, basically, that we're saying are being divided. You have f of x divided by g of x, and we want to take its derivative. And again, you can't simplify those two functions. So what does that look like in terms of the rule? So what this is basically saying is the one that's in the bottom, the low, the g of x, it goes first. So low times the derivative of the one that's on top or high. And so that's at minus the one that's on top times the derivative that's on the bottom, all over the bottom squared. A fun way to remember is low d high minus high d low all over low squared, or low low. So low d high minus high d low all over low squared. Low d high minus high d low all over low squared. Low d high d low all over low squared. The thing you got to remember too is that it's a negative in between, not a positive. The product we added, think about if it helps your exponents, you add the exponents when you're multiplying, but when you divide exponents, you subtract. And maybe that'll help you remember this. So let's do some examples of how to use this. Oh boy. So what we want to do is, how do I do natural log of x over x squared? I'm sure you would all agree here that you can't actually divide that. You can't simplify that. So what we're going to do is low, so x squared, times the derivative of high, which is 1 over x, minus high times the derivative of low, all over low squared. So x squared would be squared. So just to simplify this, and yes, you're going to want to do that, the x's simplify, so I'm left with x minus 2x ln x all over x to the fourth. And you might think, well, that's good enough. But see, there's an x in common with all of these that I can actually divide out. So I'm going to have 1 minus 2 ln x all over x cubed. And that's how I would simplify that. Hopefully that makes sense to you all. All right, let's try another one. Okay, great. So now let's do this one. X cubed over x minus 1. Again, you cannot simplify it. You can't break apart the family there down at the bottom. So we're going to go back to our rule. Low times the derivative of high minus high times the derivative of low, all over low squared. You'll notice I don't multiply that denominator out. Frequently on the multiple choice in the CLEP exam, you won't see it multiplied out. And it allows me that when I actually simplify here at the top, and I will do just that, there might be an opportunity to where I can actually simplify or factor, and then it just prevents a step. So again, I just distributed the 3x squared to both parts. So I have the 3x cubed minus 3x squared. Then we have the minus x cubed from here. And yeah, in fact, that can simplify again. We would have 2x cubed minus 3x squared over x minus 1 squared. And then I might see, oh, okay, both of them have an x squared in common, but I'd be left with 2x minus 3. And of course, nothing can actually simplify. So this is good enough as my answer. All right, why don't you go ahead and try the next one? And this computer is wigging out on me, so hold on just a second. Okay, I know you didn't hold on, but I did. I had to pause that for a second and fix that. So here's what we basically want to do. We want to do these last two examples. So if you could, I'd like you to pause the video now, and I'd like you to try these two. Let me give you a quick little note of caution here. That first example you see there, x cubed over 5, there is an easier way. Since it is a constant, there is a better way than doing the product rule. But please try the product rule anyway and show that it actually does work. So go ahead, pause the video, and see that it works. If you haven't paused the video, please do so at this time. But I'm going to go ahead and start explaining how to do each of these, just so that I can talk you through it after you have hopefully done this. So low times the derivative of high minus high times the derivative of low, which would be 0, all over low squared. So again, this part would basically be gone. So what we have here is 15x squared divided by the 5 squared, and so that's 25, right? And so we would divide both of them by 5, giving me 3x squared over 5. Okay, next, low, derivative of high minus high times the derivative of low, all over low squared. Now this is a doozy here, and I will tell you that the multiple choice will catch you on this, because even though you might do this process quite well, and in your own work, hopefully you did this ahead of time, hopefully you did in fact pause the video, you may not have, this might be as far as you took it, but understand that your choice may not be present. So just like last year, I want you to be confident in that answer and recognize, can I do something else to maybe get a similar answer to what they have? So what I'm doing here is I'm factoring out that negative, and I see that, oops, I forgot my x there. I have sine squared x plus cosine squared x all over sine squared x. And if you remember from last year, sine squared plus cosine squared equals 1. And so you might actually see this as your answer, negative 1 over sine squared x. That might be a choice. Or how else could I write that? What is negative 1 over sine squared x? That's what I'd like you to come to class with tomorrow. What is negative 1 over sine squared x? And that's my way of checking to see if you actually listened to the end of the video. Anyway, ticket today, low-de high minus high-de low all over low squared, the quotient rule.